Partial label learning is a significant weakly supervised learning framework, where each training example corresponds to a set of candidate labels among which only one is the ground truth label. Previous partial label learning researches typically assume that the candidate label sets are given for all training examples. However, the reality is that there is often only a small amount of partial label data and a large amount of unlabeled data. In this semi-supervised partial label learning scenario, the existing methods exploit the information in unlabeled samples by selecting high-confidence unlabeled samples as the pseudo-labels based on the maximum value of the model output. However, the scarcity of labeled samples and the ambiguity from partial labels skew this strategy towards an unfair selection of high-confidence samples on each class, most notably during the initial phases of training, resulting in slower training and performance degradation. In this paper, we propose a novel method FairMatch, which adopts a learning state-aware self-adaptive threshold for selecting the same number of high-confidence samples on each class, and uses augmentation consistency to incorporate the unlabeled samples to promote partial label learning. In addition, we adopt the candidate label disambiguation to utilize the partial labeled samples and mix up the partial labeled samples and the selected high-confidence unlabeled samples to prevent the model from overfitting on partial label samples. Extensive experiments on benchmark datasets clearly validate the superiority and effectiveness of our method, especially when facing fewer partial label samples with higher partial rate.